So in this lesson we're going to have a look at the induction question for the 2013 Extension 1 HSC, where we needed to prove an inequality by induction. So the first step was to show that for k is greater than 0, 1 on k plus 1 all squared minus 1 on k plus 1 on k plus 1 was less than 0. Now the best thing to do here would be to combine all the terms on the left hand side into one and show that it gives you something negative. So to do that, all we're going to do is write all the terms over a common denominator. And of course when we look at the denominators we've got here, we can see that the lowest common multiple of those denominators is k times k plus 1 squared. So if we have a look at the left hand side, we've got 1 on k plus 1 all squared minus 1 on k plus 1 on k plus 1. And then of course if we write that all over a common denominator of k times k plus 1 all squared, well, the first term we've just multiplied by k. The second term we need to multiply it by k plus 1 squared. And the last term we need to multiply by k times k plus 1. So we're going to expand all of that numerator now and hope that we end up with something negative. So when we do that, we get k minus k squared minus 2k minus 1 plus k squared plus k all over k times k plus 1 squared. And when we tidy the numerator up, well, all the k's cancel out, the k squared terms cancel out, and we're just left with minus 1 over k times k plus 1 all squared, and that's less than 0, since that denominator is always going to be positive. It's a squared term times a positive number. So that's when k is greater than 0. Okay, now we're going to have a look at the induction part of the question. So use induction to prove that for all integers n is greater than or equal to 2, that sum on the left hand side, which is 1 over the sum of all the square numbers, is less than 2 minus 1 on n. So the first thing to notice is that we need to prove if n is greater than or equal to 2. So using n equals 1 as our starting value won't work here. The smallest value that it should work for is 2. So we're going to test n equals 2 first of all. When we do that, the left hand side is going to equal 1 over 1 squared plus 1 over 2 squared, which is of course 1 plus a quarter. So that's 1 1/4 or 5 over 4. And the right hand side, well, it equals 2 minus 1 over 2, which is 1 1/2. And now we can see that that's greater than the left hand side, which is what we want. Therefore it's true for n equals 2. The next step, we would go down the page, but I'm running out of room here, so I'm just going to go over here. We're going to assume that it's true for n equals k. So we're going to assume that it works for some value, and when we do that, we get 1 over 1 squared plus 1 over 2 squared, all the way up to 1 over k squared. That's less than 2 minus 1 over k. So that's our assumption. And then the next step, of course, is to prove that it's true for n equals k plus 1. So I'm just going to write down what it is we actually need to prove to do this. So what we're required to prove is that 1 over 1 squared plus 1 over 2 squared, all the way up to 1 over k plus 1 squared. We need to show that that's less than 2 minus 1 over k plus 1. Okay, now if you have a look at our assumption, well, we can start by just adding k plus 1 squared to both sides of that. And if we do that, then we'll end up with the left-hand side that we're trying to prove. So we'll start by saying, okay, well, 1 over 1 squared plus 1 over 2 squared all the way up to 1 on k plus 1 squared. Well, that's definitely going to be less than 2 minus 1 over k plus 1 over k plus 1 squared. So now we've got the left-hand side. Now I just want to show that it's less than this value here. So this is where clever students will think back to the previous part of the question and realize that in step 2 we actually showed that this value here was less than minus 1 over k plus 1. So actually I should have written here, this is using our assumption that we got this line. So I'll add that. And so our next line is to realize that that looks like the expression we had in the previous part of the question. So this is now less than 2 minus 1 over k plus 1. How did I get that? Well, I used the first part. And that expression there is what we've got. So therefore it's true for n equals k plus 1. And we have proven that it's true by induction. And we're done. Hope that helps.